In this section, we're going to look at some more rules for differentiation, and learning outcomes are use the product rules. That's a new rule we're going to get for finding the derivatives of a product of functions. Use the quotient rule for finding the derivatives of quotient of functions, and extend the power rule to functions with negative exponents. So our power rule is pretty interesting. It's our product rule, excuse me. If we're taking the derivative of a product, that derivative is going to be the derivative of the first factor times the second factor plus the derivative of the second factor times the first factor. And if you want to use this other notation with these j of x for this joint function, we have f of x times g of x. The derivative of j of x is f prime of x times g of x plus g prime of x times f of x. So the derivative of the first times the second as regular, plus the derivative of the second times the first one as regular. Here's some proofs if you want to see it. And just remember the commutative property, a plus b is b plus a, and a times b is b times a. So let's do an example here. For j of x equals f of x times g of x, use the product rule to find j prime of 2. If f of 2 equals 3, and f prime of 2 is negative 4, g of 2 is 1, and g prime of 2 is 6. So our j prime of 2 is going to be f prime at 2 times g of 2 plus g prime of 2 times f of 2. So our f prime of 2, is negative 4 times g of 2, which is 1, plus g prime of 2 is 6, and f of 2 is 3. So I have negative 4 plus 18 equals 14. Let's try another one. j of x equals x squared plus 2 times 3x cubed minus 5x. Find j prime of x by applying the product rule. Okay, and we can check this by distributing and then just use the power rule. So our j prime of x is going to be the derivative with respect to x of the first one, which is x squared plus 2, times the 3x cubed minus 5x. Slide this over here. And then plus the derivative with respect to x of the 3x cubed minus 5x times the x squared plus 2. So what do we have? I have 2x from this derivative of x squared plus 2. That's going to be 2x times our 3x cubed minus 5x plus, and then this derivative, the 3x cubed, that derivative is going to be 9x squared minus 5, because the derivative of 5x is 5, and times the x squared plus 2. So if I distribute this, I'll end up with 6x to the 4th minus 10x squared plus 9x squared times x squared is 9x to the 4th plus 18x squared minus 5x squared minus 10. So 6x to the 4th plus 9x to the 4th is 15x to the 4th. What do I have? I have minus 10x squared plus 18x squared. That's 8x squared minus 5x squared. So I get plus 3x squared and then minus 10. Okay. Now let's try the other if we just multiply this out. So if I said my j of x was, that's going to be x squared times 3x cubed minus x squared times 5x plus 2 times 3x cubed minus 2 times 5x. We'd have 3x to the 5th minus 5x, what's that, 5x cubed plus 6x cubed minus 10x. It's going to be the telltale sign if I got this done, if I did my math right in my head. 3x to the fifth plus x cubed minus 10x. So if that's the case, j prime of x, j of x prime, excuse me, should be a 6x to the fourth plus 3x squared minus 10. So I must have a sign issue up here. I had a 6x to the fourth, and then I had that 9x to the fourth. It came from 9x squared times x squared. Okay, I see my problem here is I don't do math in my head well. This derivative of 3x to the fifth, that 5 would come out and multiply by the 3. So that's going to give us, what we're after, is our 15x to the fourth. Now, matches up. So that should be 3x squared. Okay, yay! Let's look at the next one. Use a product rule to obtain the derivative. So if we look at this, we would have j prime of x, j of x prime. It's going to be equal to the derivative of the first thing. So 2 times 5x to the fourth times the 4x squared plus x plus the derivative of 4x squared plus x, so 8x plus 1 times 2x to the fifth. So our j of x prime is going to be 10, more than that. So 2 times 5 is 10, times 4 is 40. X to the fourth times x squared is x to the sixth, plus 10x to the fifth. That's 2 times 5 times x to the fourth times x. Then plus 8x times 2 is x to the fifth. It's going to be 16x to the sixth. And then I have 1 times 2x to the fifth plus 2x to the fifth. So I'm coming up with 40 plus 16 is 56x to the sixth. That's pretty big. And then I have plus 15x to the fifth. Once again, a little math error. 10 plus 2 is actually 12, not 15. And that's it. For this problem, we want to look at finding y prime, but we're going to look at it doing it two ways. One is by using the product rule, and the other is by distributing the 4 minus x squared times x cubed minus 6x plus 5, and then taking the derivative. So in the first case, let's see, we have, we're going to call u the 4 minus x squared and v the x cubed minus 6x plus 5. So our, this is a little bit out of order the way we were doing it before. This is going to be our, like our dv. So they're saying dv is the derivative of the v part, and du is the derivative of the u part. So this would be our du. So if we're saying, they're calling this y equals uv, and they're saying y prime equals u dot v prime, or dv, maybe I'll call it v prime, plus v dot u prime. I'll call them primes instead, that way we're more familiar with what we've been doing before. So I'm going to call this v prime and call this u prime. So if my u happens to be 4 minus x squared as they defined it. U prime would be negative 2x. And if my v happens to be x cubed minus 6x plus 5, the v prime would be 3x squared minus 6. So this becomes a 3x squared minus 6. Down here, the u prime becomes a minus 2x. And at this point, you would distribute each of these to come up with our final y prime. What they want us to do in part B is to come up with our y if it's distributed. So if you look at y as being the 4 minus x squared times x cubed minus 6x plus 5, y would equal 4 times x cubed is 4x cubed. Guess I don't need the parentheses. 4 times minus 6x, so it's minus 24x. 4 times 5 is plus 20. And I'm just going to move it over to give myself more space to work here. The negative x squared times x cubed is minus x to the 5th power. Negative x squared times minus 6x is plus 6x cubed. And negative x squared times 5 is minus 5x squared. So y equals, now if I simplify this and combine all the terms, like terms, I have minus 5x, no, minus x to the 5th, excuse me. And then we have a plus a 10x cubed. And then we have, so that's a 4x cubed and a 6x cubed. And then we have a minus 5x squared. And then we have, say, a 24x. That's the only one. Yeah, so minus 24x. That's only an x term. Then we have a plus 20. So our derivative is going to be that negative of 5x to the 4th plus 30x cubed minus 10x, that's 2 times 5, and then minus 24, and of course the derivative of the constant is 0. So we come back over here and we can write this. The y was a it was a negative x to the 5th. Oh, there's a dead spot. Forgot about that. Negative x to the 5th plus 10x cubed minus 5x squared minus 24x plus 20. And the derivative was negative 5x to the 4th plus 30x cubed minus 10x minus 24. And that's the same answer as if you distributed the ddx of uv up on top. So there you go. Okay, moving on. The next rule is called the quotient rule. Remember, quotient means fraction. So the quotient rule says let f of x and g of x be differentiable functions. Then the derivative with respect to x of f of x over g of x. So g of x is the denominator, f of x is the numerator. Is the derivative of the f part times, that's the numerator, times the denominator, minus the derivative of the denominator part times the numerator over the denominator squared. Or, as they put it with this j notation, it is j prime is f prime of x times g of x minus g prime of x times f of x over g of x squared. There's another way of saying this, and that would be, how do I say this? I'll just go through j. J prime of x is low d high minus high d low all over the square of what's below. Low d high, that means the low part of the denominator, times the derivative of the high part of the numerator, minus the high part or the numerator, times the derivative of the low part or denominator, over the square of the denominator. Low d high minus high d low, all over the square of what's below. So now we're asked to use the quotient rule here. So let's find k prime of x. K prime of x is going to be low, which is our 4x plus 3. Now I'm going to do that in parentheses because I have to distribute the whole thing, times the derivative with respect to x of 5x squared minus high, which is 5x squared, times the derivative with respect to x of 4x minus 3 all over 4x minus 3 squared. So k prime of x is going to be this 4x minus 3 times derivative of 5x squared is 10x minus 5x squared times the derivative of 4x minus 3 is 4 all over 4x minus 3 squared. And I usually leave the denominator in a factored form, factor like that. I don't expand it. So our k prime of x, k of x prime, I should say, is going to be, looks like 40x squared minus 30x minus 20x squared all over 4x minus 3 squared. So our k of x prime is going to be 20x squared minus 30x all over 4x minus 3 squared. That's it. Okay, fun stuff. And here's another one. So we have our h of x is 3x plus 1 over 4x minus 3. So our h prime of x, or h of x prime, is going to be 4x minus 3, same denominator as last time, times the derivative with respect to x of 3x plus 1 minus 3x plus 1 times the derivative with respect to x of 4x minus 3, I think I'm in the window now, all over 4x minus 3 squared. So our derivative, h of x prime, is going to be 4x minus 3 times 3 minus 3x plus 1 times 4 all over 4x minus 3 squared. So h of x prime is going to be, looks like 12x minus 9 minus 12x minus 4 all over 4x minus 3 squared. So h of x prime is going to be, those 12x's go away. I have negative 13 over 4x minus 3 squared. Okay, kind of fun. Exactly what you want to be doing on a Friday night, literally. Okay. There's a video you can watch if you want. Now the next one, we're going to do the same thing, find and simplify. So f of x equals x squared over 4 minus 7, negative 4 minus 7x. So our f prime is going to be negative 4 minus 7x. And by the way, it just does not come natural to me to put the constant before the variable term. Anyway, times the derivative with respect to x of x squared minus x squared times the derivative with respect to x of negative 4 minus 7x all over negative 4 minus 7x squared. So f prime of x is going to be negative 4 minus 7x times 2x minus x squared times negative 7. because the derivative of 4 is 0. So it's just the derivative of negative 7x, and that's just a negative 7. All divided by negative 4 minus 7x squared, quantity squared. And let's do a little bit of algebra now. So that's going to be negative 8x minus 14x squared plus 7x squared, all over negative 4 minus 7x quantity squared. So our f prime is going to be, so the negative 14x squared and 7x squared is going to be negative 7x squared minus 8x. And I'm just going to write this as negative 7x minus 4 squared. And I'll be honest, there's a big part of me that wants to factor out the negative 1 because it would just square out in the end. Okay. Hope you enjoyed that because we've got several more. Okay. Actually, the next couple are we're going to shift gears a little bit and look at that power rule in a different light. So just recall the power rule says if k is any integer now, it could be a negative integer, it's still going to apply that the power comes out front and we subtract 1 from the power. So in a case like this, d dx of x to the negative 4, so that's going to be negative 4 times x to the negative 4 minus 1, which is negative 4 times x to the negative 5. The next one, you can rewrite this f of x equals 6 over x squared to be 6x to the negative 2, so that f prime of x is going to be 6 times negative 2 times x to the negative 2 minus 1. So that's going to be negative 12x to the negative 3, or negative 12 over x cubed. I should have written this up here as negative 4 over x to the 5th. I'm not sure how they want their answer, but both of those work. They're equivalent. Next one, g of x equals 1 over x to the 7th, so we can write that as g of x equals x to the negative 7. So g prime of x would be negative 7x to the negative 7 minus 1, which is negative 7x to the negative 8. So that'd be negative 7 over x to the 8th. Okay, got one more here. Now this one, they want us to find f prime of 1. So I'm going to say f of x could be written as 2x to the negative 2, to bring that up. So f prime of x is going to be 2 times negative 2 times x to the negative 2 minus 1. Our f of x prime, or f prime of x, is negative 4x to the negative 3, or negative 4 over x cubed. So if we look at the first derivative at 1, that's negative 4 over 1 cubed, which is negative 4 over 1, which is negative 4. That's it. And that will do it for this section. Okay, I hope you had fun.